Yeah, good afternoon, all of you. If my voice is audible, if my voice is audible, yes, if my voice is audible to all of you, if you not respond, so how do you know whether you are listening to me? Yes, if my voice is audible,
Yes, sir.
okay. So wait for a minute to others to join. So you can see the list of the program that we will going to implement today. Okay, just go through this. Okay, just go through these programs for what we have to implement today. So what we have discussed in the class, okay, so basically we will implement all the programs related to DFT, okay, discrete Fourier transform. Okay, you can scan this QR code for the attendance. Okay, so let's start the today's session. So as you can see the list of the program that we have to discuss today. The first program is your, we will write a Matlab program which can be used to compute your two-dimensional discrete Fourier transform of a given image. Okay, the given image will be given in the form of spatial domain. So we will write a Matlab code to convert that given image in your uh, frequency domain, or we will convert to discrete Fourier transform. Similarly, we will write a Matlab program to convert our from the frequency domain to the actual time domain with the help of inverse discrete Fourier transform. Fine. Then we will use the built-in Matlab function for about these two programs. Then we will learn how to find the magnitude spectrum, how to find the phase spectrum, and how to find the power spectrum. Okay, so with relevant to the frequency domain. Then we will write a program to understand or prove the convolution in your uh, for DFT. Okay, for DFT, for which we have learned the convolution theorem that will be going to perform. Then we will explain the Matlab code to demonstrate the rotation property of the DFT. Okay, so today as we discuss the rotation property, how rotation will affect in your time domain as well as in your frequency domain. Then we will take a example where we consider two images and we will interchange the phase of these two images and we will analyze what changes will appear in your actual images. Fine. Then program number 8, we will write a Matlab program to convert your RGB image or color image. Okay, that will be converted to the grayscale image. How we will convert the color image or RGB image to grayscale image. Then we will run the Matlab command for the resizing any image. the size of the image, you want to reduce it. Okay, basically the pixel. We will reduce the pixel. Okay, we will not perform the, or we can say we will not change the altitude of the images. We will just reduce the size. Okay, from 512 to 512 to 256 for 256. In the last program, that we will write a Matlab program to display the different component of RGB image. That is the red component, green component, and the blue component. Okay, so these are the Matlab programs that we will going to implement today. Fine. So let us start. Okay. So before starting, so let me explain once again what you mean by DFT. So now again, suppose the f of x is given a signal. Fine. Then f of capital UV represent your what? F of capital UV represent your Fourier transformation. Okay. So if I want to find the Fourier transformation in a 2D, okay, two-dimensional discrete Fourier series DFT. Okay. So what is the formula for that? Yes, anyone can say what is the formula for that? What formula we have derived for two-dimensional discrete transformation? क्या फॉर्मूला यूज किया हम लोगों ने? It will be, now you have to participate. Okay, इतना पूछने से बताना पड़ेगा आप लोग को, नहीं तो फिर मेरे को समझ में नहीं आएगा आप लोग क्या समझे. It will summation of x equal to 0 to n minus 1, then summation of y equal to 0 to n minus 1. Fine. Now f of x, y, your real image, then e to the power of minus j, okay, 2 pi n ux plus vy. So this is a mathematical formula which is given. Yes or no? This is a mathematical formula which is given for the discrete Fourier transformation. Similarly, we have having IDFT. Yes or no? Inverse discrete Fourier transformation formula. So which is given by f of x, y will be equal to 1 upon n. Okay. Now u equal to 0 to n minus 1. Now summation of v equal to 0 to n minus 1. Now it will be capital f of uv e to the power of minus j 2 pi n ux plus v1. Okay, so these are two formula, mathematical formula for your. This is for the frequency domain, or I can say this is the DFT formula, which is denoted by capital F of uv, and this is your inverse DFT, which is give your actual image, which is f of xy. This is the formula. Fine. So along with that, we have also learned the different spectra. Okay. One is your power spectrum, which is nothing but mod of f of uv. Okay. What is the formula for that? It is the root over your real component x and y ka whole square plus your imaginary component, because the Fourier transform which is represented, it is represented in complex format. Okay, क्योंकि actually represented होगा आपका ये f of u comma v e to the power of minus j 5 u. Fine, this is actual representation which is in complex format. So there will be a real part and there will be imaginary part. And square root of these two functions will give the magnitude spectrum or Fourier spectrum. Similarly, phase angle theta is given by tan inverse. Okay, now it will be u of uv by your real part of, okay, right, u comma v. Similarly, the power spectrum, which is represented by p of uv, which is nothing but square root of this magnitude spectrum. Find square of this. Okay, so these are the formula that we have already learned relevant to the your DFT or 2 DFT. Is it clear? So we have already discussed this one in the class. Fine. So let me write an example how we can use this formula while converting the images to the different domain. Fine. So in general, so what actually happens now, whenever you want to create any signal, so कभी भी हम signal बनाते हैं, suppose you want to convert a signal or we find a particular signal, so we are basically using the base function. Yes or no? I already discussed the base function. So base function is nothing but are building blocks of any element. Okay, a simple building blocks of any element. Okay, so the f of u is basically given by, okay, this f of u basically given by कैसे generate होगा? Now it will be your base function, okay, multiplied by your actual image, okay, actual image matrix, okay, then it is multiplied by your base function transpose. Find base function का transpose. Okay. Now your base function is also called kernel function. So which is nothing but a basic building block. Okay. Basic how the image or how when we are converting this image to the Fourier transform. Okay. So we are using some basic functions or unit functions. So these are the unit function which is already defined. Okay. Already defined, and these functions will be used while converting your any image to the frequency domain. Fine. So sometimes this base function is also called kernel. So we can write the or we can write the formula as v of uv will be equal to, I can write kernel star multiplied by actual image, then it will be transpose of your kernel. Fine. So let us try to solve this one problem, okay, mathematically. Then we will implement with the help of the command. So do remember this formula. Actually, how we are converting. So we are basically converting with the help of the base functions. Okay. So let me put the questions. So now write down. Suppose now I have supposed you to find the 2D DFT of the given matrix. Okay, the matrix is given as f of x, y. The matrix is something like 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so this is 4 cross 4 matrix. Fine. This is 4 cross 4 matrix. So you have to find the f of uv. F of uv is the frequency domain of this matrix. Okay, or we can say frequency domain of this image. So when you will draw this image, so it will be in white format. It will 4 cross 4. Okay, all the values are 1, so it is black and white image. So all the coordinate will be 1, or we can say white. Fine. Now the base function for this 4 cross 4 matrix is given as, okay, the base function of kernel is given as, okay, it is predefined. The kernel is always predefined. याद रखना है, हर एक साइज के लिए kernel का different value होता है. Fine. For 4, kernel equal to 4. Okay, 4 cross 4 matrix, the kernel is given as, so value is 1, 1, 1, 1, 1, minus j, fine, minus 1 and plus j, then 1, minus 1, 1 and minus 1, then 1, j, minus 1 and minus j. Fine. So this is the kernel for the 4 cross 4, or I can say this is a base function. Okay, this is my base function which is given. Okay, or it is fixed. Okay, base function is fixed for 4 cross 4 matrix which is given by this one. and this is the image. Okay, given in focus 4 dimension. Then what you have to find? I have to find the frequency domain f of uv. So we know that the formula. So what is f of uv? Now to calculate f of uv with the help of base function, so I can use, what is the formula? So I can use like this kernel value. So this 1 1 1 1 1 minus j minus 1 plus j, then 1 minus 1 1 minus 1 1 j minus 1 minus j into, okay, multiplied by your actual image, which is your f of xy. So it is all 1. Okay, so these are all 1, these are all 1, and these are all 1. Fine, and it is multiplied by your transpose of this curve. The transpose of this curve. So first you find transpose matrix. 1 1 1 1 1 minus j minus 1 minus j 1 minus 1 1 minus 1 1 j minus 1 minus. So is it clear? So how we are finding? So finding of f of uv, that means frequency domain. Nothing but what formula we discussed? It's nothing but kernel into your f of x, okay, into your transpose of kernel. Fine. So what will the answer? So anyone can tell me the answer? What will the answer when you multiply these three matrices? So what will the final answer of this one? Yes, what will be the resultant matrix? So it will 4 cross 4, no doubt, because as all are 4 cross 4, then what is the final output? Yes. What will be the answer for this problem? Is I audible to all of you?
Yes, sir.
Yeah, what is the answer? तो क्या कर रहे समझ में आया हम लोग को?
So 1 1 1.
आफ्टर मल्टीप्लाई तीनों मैट्रिक्स को या
यस सर. सर तीनों मैट्रिक्स को मल्टीप्लाई करने के बाद जो रिजल्ट सेम होगा सर फर्स्ट वाले के ही इतना.
ये j है, ठीक है. j इज अ कॉम्प्लेक्स नंबर, रिमेंबर. j is a complex number here. Okay, this is not 1. This is j. This is a complex number. This is also j. Okay.
Yes, sir.
So when you multiply complex number, there two terms will become. One is real part, one is complex part. Fine. So you can solve this one. Okay, the answer. Let me write the answer. I will write. Don't waste time here. So it will give, when you compute this particular one, the answer will be 16 0 0 0. Then rest all are 0 0 0 0 0 0 0 0 0. So this will be your final answer, which is nothing but your frequency domain. ठीक है. So once again, तो अगर किसी भी इमेज या फिर किसी भी टू मैट्रिक्स दिया होगा 2 डायमेंशन में x and y, okay, तो to convert this image of matrix to frequency domain, that is अगर इसके फंक्शन पर अगर f of x y पर हम लोग अगर DFT यूज करेंगे, ठीक है, तो it will convert it to f of uv. Fine, you can either use the mathematical formula or we can derive this f of uv with the help of base function also, because all the signal that is formed or all the images that is formed, that will be basically generated from a base signal. ठीक है, और base function बोलते हैं या kernel बोलते हैं. Okay, so what is the formula for generation? This one for u of uv can be given as, okay, this is your kernel or base function into your actual image, okay, and transpose of the kernel. For every matrix, that is 2 cross 2 के लिए kernel अलग होगा, 4 cross 4 के लिए अलग होगा, 8 cross 8 के लिए अलग होगा. The kernel will be, for every matrix it will be different, because for every matrix the base function will be different. पर 4+4 कर्नल के लिए 4+4 मैट्रिक्स के लिए दिस इज योर कर्नल मैट्रिक्स, दिस विल बी गिवन. ओके, दिस इज योर कर्नल मैट्रिक्स. So when we apply this method, so we'll get this answer. Fine. So now what we will do, so now we will write a Matlab program. Okay, we write a Matlab program to compute this process or to convert or find the DFT. Fine. Okay, is it clear to all of you? The first program, so you have to find the DFT of a given image or particular. We will find the particular whether they are getting or not. Okay. Clear this thing first. Yeah. So first, what we have to do now? First, you have to create an input matrix. So let me create a matrix. So we need an image first. So let me write input image. Okay. So how to create a matrix? How to create a matrix? So we will use a which type of bracket? A square bracket. Okay. So how many rows and how many columns?
Square
4 rows. Yeah. 4 rows मतलब 4 values space है और rows separated कैसे होता है? By column.
सेमीकोलन.
यदि आप सेमीकोलन देंगे तो एक रो खत्म होगी. ठीक है. Then 1 1 1
फिर सेमीकोलन.
हाँ सेमीकोलन देंगे तो फिर से 1 1 1 1 फिर से एक सेमीकोलन, रो खत्म हो गया, फिर से 1 1 1 and 1. Now this matrix is completed. Okay, now you can see तब मैं enter करूंगा. Now you can see the output of the matrix. Now this is my f of xy. ये जो input image है हम लोग का क्या है? f of xy. This is my f of xy. Fine. Now what I have to do? Now next I have to find the kernel. Yes or no? Kernel को define करना है. Now for every matrix मैंने बताया kernel will be different. So I will find the kernel. Kernel equal to. Now there is a Matlab predefined function which is called DFT MTX. Okay. So this function name क्या है? DFT MTX. So this basically determine the kernel for particular size. So now what kernel we require? Size of 4 चाहिए हमको. ठीक है. क्या चाहिए हमको? Size of 4 चाहिए. तो क्या कर रहे हैं हम लोग? Now size of 4 मैट्रिक्स के लिए हम लोग kernel को डिफाइन कर रहे हैं. Fine. You can see आपका जो kernel जो हम लोगों ने वैल्यू लिया था, पहला वैल्यू आप क्रॉस चेक कर सकते हो. पहला वैल्यू क्या था? 1 था. देखो ये रियल पार्ट का वैल्यू 1 है, इमेजिनरी पार्ट का 0 है. फिर रियल पार्ट का 1 है, इमेजिनरी पार्ट का 0 है. रियल पार्ट 1 0 1 0. सिमिलर नेक्स्ट इंडेक्स देखो 1 देन माइनस j क्योंकि इमेजिनरी पार्ट है आपका, देन -1 देन प्लस j. फिर क्या है? 1 देन -1 1 -1. नाउ 1 देन योर plus j, then -1 -j. Okay, we have defined the kernel for the 4 matrix. Fine. Now you have to find the Fourier transform. So let me write as output. Okay, so output equal to what is the formula? Formula will be, so I will write kernel. Okay, kernel into. Okay, so I will give the image. हम लोग का image कहाँ है? In the variable called input image. Fine. Now again multiplication क्या रहेगा आपका? Transpose of the kernel. So I will find the transpose. So how to find that? How to find in the Matlab? Simply आप यहाँ पर एक dash देना. Okay. Now kernel
dash
ऊपर देने से बताया था मैं पहले ना. Okay. Now let's see. We will calculate. Now
yes.
The output variable क्या है? देखो आपका this is your output variable. So this matrix, the output matrix is your actual, we can say DFT of this image. Okay, this का ये जो है आपका क्या है? ये आपका FUV है, FUV है. और I can say यहाँ पर हम लोगों ने DFT, discrete Fourier transform process. Fine. So this formula you have to remember. Okay, this formula you have to remember how we are converting. Fine. Now kernel is very important. Now can जब हम लोग यहाँ पर 8 लिखेंगे तो it will find the kernel for 8 × 8 matrix. If you want 16 matrix, where 256 का है. If if your image is generally 256 cross 256, the grayscale elements कोई भी लेते हैं हम लोग, it will be generally 256 cross 256. Then you find the what kernel for 256. Fine. So just note down this one. Quickly note down this one. समझ में आया सभी को? Is it clear?
Yes, sir.
So write down. So once it is over, तो मुझे बताना पड़ेगा. So we will move to the next problem. So note down because you have to submit these questions, okay? Because this assignment is given in your LMS. So these are the questions, you have to write the program for this. All. So do note down the programs, okay? Okay. So is it completed? Is it completed?
Sir, एक मिनट. क्यों कर रहे हैं हम लोग ट्रांसफॉर्म? क्या रीजन है? Why we have to convert from one domain to another domain? What is that need? Yes, anyone? What is the need of converting one domain to another domain? Yes. What is the need of image transform, or what is the need of transformation? Yes. नहीं बताएंगे कोई आंसर? Because so that we can extract more information. Okay, और pre-processing जो है that will be much easier. And other advantages also there, like convolution are implemented as multiplication. Okay. So that is the reason we are performing this either whether you're performing discrete transformation or discrete cosine transformation or wavelet transformation. Okay, so it will be helpful to better analyzing purpose. Okay, so let's move on to the next program. Okay, so now Matlab is having a built-in function. So instead of writing all these things, okay, so Matlab is having a built-in function which is called FFT2. Okay, क्या है built-in function of FFT2? Now you can check here in the Matlab. So if I write here help, okay, FFT2, I can see what is display. Take 2 minutes. So just wait. Yes, now you can see. Now, what is FFT function? What is the FFT function? Now, FFT2 is a built-in function that will be used to convert. Okay, so that will be basically used for conversion or transmission of discrete Fourier transformation. Fine. So now we will see how this function, how we can use this built-in function for finding the same result. Okay, is this clear? So let me put image is already there, so no need to create once again. So I will just whether it's working or not. Yes, the input image is already there because as we can see in our workshop, okay, the input image is already there, which is one. Now instead of writing the code, now I will use the Matlab built-in function, which is, let me write output is equal to, so what is the Matlab built-in function? So FFT FFT2. Okay, FFT2. Then you have give the input image. The name of the input image is now here input image input underscore image. Okay, तो अभी हम लोगों ने क्या किया, instead of finding the kernel and writing the formula, MATLAB में क्या है, आपका इनबिल्ट फंक्शन है FFT2 जो आपको कन्वर्ट करेगा आपका टाइम डोमेन से फ्रीक्वेंसी डोमेन. Fine, or basically it will perform DFT. So you have to give the input. Input will be any image format. Okay, any image or matrix you can give. Fine. So if I write this one and execute it, so you can see the output is similar. Same I can output. Output is very much similar. So either you can use this built-in function or you can use that mathematical formula to find the DFT of any image. So it is clear to all of you? Is it clear?
Yes, sir.
Yes, sir.
तो अब से हम लोग ये फंक्शन ही यूज करेंगे जब भी हम लोग को DFT निकालना है, तो we will use this function. Okay, we will use this function FFT2. Okay, and there is one more function FFT-N. Okay, N क्या है? For basically for grayscale image. कभी-कभी grayscale image और 8-bit यूनिट के लिए कभी-कभी FFT2 वर्क नहीं करता है, तो either we will use FFT2 or FFT-N. Okay, fine. So now let's discuss the next one, how to find the inverse. Okay, inverse DFT. Fine, inverse DFT. Now same function. Now suppose this is my f of u. f of ub क्या था हम लोग का? f of ub था हम लोग का 16 और उसके बाद सब 0 था, ठीक है नहीं? सब वैल्यू हम लोग का 0 है. और अब हम लोग क्या करेंगे, इस पे अगर IDFT लगाएंगे, इनवर्स डिस्क्रीट फोरियर ट्रांसफॉर्मेशन अगर करेंगे, इनवर्स डिस्क्रीट फोरियर ट्रांसफॉर्मेशन, तो हम लोग को क्या आएगा, एक्चुअल इमेज आएगा. आगे नहीं, आई विल गेट द एक्चुअल इमेज. यस, करेक्ट है कि नहीं? अगर IDFT यहाँ पर यूज करेंगे हम, IDFT दैट इज इनवर्स डिस्क्रीट फोरियर ट्रांसफॉर्मेशन, so it will give back the actual image. So what is the formula here? Now the formula will be same but with slight difference. So it will be 1 by n square. Okay, 1 by n square, which is multiplied by your kernel into your f of uv image multiplied by kernel of transpose. Fine. Now if you apply this formula, what is the n? N is a 16, so 1 by 16. So what is kernel matrix? The kernel matrix will be same, that is 1 1 1 1. Now next will be 1 minus j minus 1 j, then it's 1 minus 1 1 minus 1 1 j minus 1 minus. This is kernel matrix. Then what is your f of uv? Now this will be f of uv, this is 16, rest all are 0. The rest all are 0. Similarly I can find k of t. So when you multiply this, what should be the answer? What should be the answer? Answer क्या आना चाहिए? Yes, what should be the final output? What will be the final output f of xy? क्या आना चाहिए? It should be your actual image, है कि नहीं?
Actual image.
Actual image क्या था आपका? All are 1. Actual क्या था आपका? मतलब 1 था. तो यहाँ पर क्या किया? DFT के तो ये आना है. IDFT करने से क्या आएगा? Actual image आना चाहिए. मतलब all the values should be 1 आना चाहिए. Fine. All the values should be 1. Fine. So let me write the MATLAB program. So this is a concept. So the same formula will be something same, but n 1 by n square करेंगे यहाँ पर. Fine. So let me write the MATLAB program for this. Okay, so output image is already there in output, so we will create a kernel. Okay, we will create a kernel. So kernel is also there, no need to create a kernel. So why I'm not creating, otherwise you have to create. Okay, let me clear the workshop first. So what is the command we have used to clear the workshop? Clear all. Okay. Clear all लिखने से जितने भी वेरिएबल से वर्कशॉप में वो डिलीट हो जाएगा. Fine. So let me take the input image. Find CLC for the field in the window. Okay. So let me write the input image. Packet. So values are 16. Rest are 0 now. Then semicolon. All zeros, 4 zeros. Then semicolon. 1, 4. Again semicolon. 1, 2, 4. Fine. I can see this is my input image. It is your f of u. Now first I have to find the kernel. Okay, so what is the how to find the kernel? Which formula should we use? DFT matrix. Okay, MTX. So which size? Size is 4. So it will give the DFT matrix. So now the output. So finding the output. Output will equal to what? 1 by 16 because n equal to 4. Okay, 1 by n square. So I am taking 1 by 16 multiplied by your kernel multiplied by your input image, input underscore image, input underscore image. Okay, then multiply by your again kernel the transpose. Second, yes, the transpose. Yes. Now you can see the output. Is the output here? Is the output still correct? Yes. What we are getting now, we are now when we are performing the IDFT. Now you can see the output is now when I perform the IDFT here. IDFT. Okay. So what actually we get? To actual f of x, y, r. Okay. Similarly, we are having a built-in Matlab function. Like we have the built-in Matlab function FFT2. Now here the built-in Matlab function which is used is IFFT2. Okay, so let me write the output again. Output is equal to IFFT2 of input underscore. Okay, you can see both the outputs are true. Either you can use this formula or you can use this built-in function. Okay, now this is a built-in function name which is IFFT. I hope it is clear to all of you. Yes.
Yes, sir.
Yes, so कुछ doubt है? So you can note down. So there is less than 1 minute. Okay, once the link is over, do rejoin the link again. Fine. So you can note down this one within this 1 minute.